In this example, we want to consider the following simple statements. P is I study hard, Q is I get an A, R is I am happy. And remember, statements are defined as declarative sentences that are either true or false. So in other words, they are not opinions, questions, commands, or explanations. So the first thing we want to do is we want to write the given compound statement symbolically. So for part A, the compound statement is if I study hard, then I get an A. And we see that this is P right here, and I can see that Q is here. And whenever we have the if-then format, you might not always see the then. You might see if I study hard, I get an A. But whenever the statement is in that form, we write it symbolically as P arrow Q. So P implies Q. And this is called a conditional statement. Okay, because it's on condition. If I study hard, if that condition is satisfied, then I get an A. For part B, we have the statement, I study hard, or I get an A. So the way that we write this symbolically is we have the P, and then the symbol we use, it looks like a little V, P or Q, and this is called a disjunction. And it basically corresponds to or statements. For part C, we have the statement, I study hard and I get an A. So the and is what's different here, but we have the same statements, P and Q over here. We write this with a little symbol like a caret symbol, P and Q. And this is what we call conjunction. So these are and statements. For part D, the statement is, I do not study hard. This is what we call negation, and we write it with a little squiggle. So that's not P. So that is called negation. For part E, the compound statement is, I study hard if and only if I get an A. Okay, so this if and only if, basically what this means is that I study hard implies, so if I study hard, then I get an A, and it also implies, and if I get an A, then I studied hard. So this is what we call a biconditional. It's the arrow works both ways. And the way that we write this is P if and only if Q. So it's the double arrow. So here's another example for you to work out. So we have the same three statements, P, Q, and R, and we want to write the sentence in symbolic form. So the sentence is, if I don't study hard, then I don't get an A and I am not happy. So this statement involves P, Q, and R. We can see it involves all three. So the key is to figure out how these statements fit together. So clearly this corresponds to P, and then we have, so this is I don't study hard, so I'm just going to write the negation there. I don't get an A, that's not Q, and I am not happy. So we can see already the simpler statements inside. I'm also going to pay close attention to the comma here because that tells me, that guides me for how to break this statement up. So what we see is a conditional here, right? And then if I don't get an A and I am not happy. So what I'm seeing is because the comma breaks the statement up between these two parts, I'm going to look at these parts separately and I'm going to read the part after the comma as not Q and not R. So I think of those as together because of the separation of the comma, and I'm going to group those together in parentheses, and then I'm going to look at the part that occurred before the comma. It says, if I don't study hard. So that is not P. Then all of the stuff that occurs after the comma. So this is a conditional statement, if, then. And as I said before, you don't always see the then. So here we have another example with the same P, Q, and R. And what we want to do in this example is write the symbolic form. It's a conjunction, and we also see disjunction here. P and not R grouped together, or Q. And we want to write this in words. So I'm again going to use the grouping. I'm going to use a comma, okay, in order to help me write this in words. So let's start with the first part. So that's I study hard. So we have conjunction here, and we have negation of R, I am not happy. And because of the grouping, I'm going to put a comma right here, and we're going to say or, so we have disjunction, or Q, I get an A. In this example, we're going to look at truth tables. And the first thing we're going to do is we're going to construct the truth table for conjunction. So remember, those are and statements. And then we're going to use it to determine if the statement is true or false. In this case, that's cats can fly, and 3 plus 2 is 5. So let's first construct the truth table. So the truth table for conjunction. When we construct a truth table for conjunction, that only involves P and Q. We are always going to start with the following two columns when there are two statements, okay? And we're always going to start with true, true, false, false, and then true, false, true, false, because this covers every possible true-false combination for two things, P and Q. Now, conjunction, if you recall, we write it with the little caret like that. Now, the way the truth table for conjunction works is that an and statement is only true if both P is true and Q is true. So if P is true and Q is true, then the conjunction is true. If P is true but Q is false, then the statement is false. Okay, and if P is false and Q is true, then the statement is false. And if they're both false, then the whole statement, the conjunction, is false. Okay, so this is the only case where we get a true conjunction. Both of the statements have to be true. So now let's look at this example. Cats can fly, and 3 plus 2 is 5. So we know that 3 plus 2 is 5. So this is true. Cats can fly. This is definitely false. Cats can't fly. So we have a conjunction here. We have basically a false thing and a true thing. So we know that that fits into this case. So this statement is false. The conjunction that we have here is false. Cats can fly, and 3 plus 2 is equal to 5. False. In this example, we're going to do something very similar. We're going to construct the truth table for disjunction. So remember, these are the or statements. And then we're going to use it to determine if the statement is true or false. So I changed the and to an or. So this is cats can fly, or 3 plus 2 is equal to 5. So let's start by constructing the truth table. And I'm only going to need P and Q here. So I'm going to start with those two columns that we always use in such a statement that only involves two simple statements. So again, these are the four possibilities, and then I'm going to put the disjunction here. Now, a disjunction, in order for a disjunction to be true, one or both of the simple statements has to be true. So if P and Q are both true, then the disjunction is true. If P is true but Q is false, it's still true. We just need one of them. And if P is false and Q is true, the disjunction is true. However, if they're both false statements, then the disjunction is considered false. Okay? So now let's go back and let's look at the statement. And we want to determine if the statement is true or false. So cats can fly, or 3 plus 2 is 5. So this is true. Cats can't fly. We already said that's false. So in this case, we have one of the statements is false. The second statement is true. So this actually, the disjunction here is true. Okay, there's one last thing I want to mention before you begin the homework, and it's just this idea of quantifiers. For example, if I give you a statement such as all cats meow, what is the negation of this statement? Is it some cats, and I'll give you a couple choices. Some cats do not meow, or is it no cats meow? So what is the answer to this question? It's very tempting to say all or none, and it's very tempting for us to say no cats meow. But the opposite of this statement that all cats meow is actually some cats do not meow. Okay, and think about it this way. This statement is false, right? But the statement that some cats do not meow is actually a true statement. And this statement, no cats meow, is also false, right? So clearly these two can't be the negation of each other.